In this video, we're going to take a look at how we can make Blazor run on top of a Raspberry Pi. In this case, it's a Raspberry Pi 02W. And we're also going to communicate with the Raspberry Pi using the Meadow framework. So let's take a look. So here we have the Raspberry Pi 02W. And this is a really nice device. It has a lot of connections. It's very powerful. And, well, let's see what we can do with it. So here it is. You see that we have a lot of different connection points. We have USB, we have the ribbon cable, and all of these really nice features. But for this demo, we're going to keep it very, very low key and very simple. We're not going to connect anything. We're just going to use the onboard LED to do things. So the onboard LED is the one down here, I believe. So this first demo is just going to show you how to set up a Raspberry Pi to be able to run Blazor, as well, make a LED blink, because that's why we're here. So to make this possible, we need to prepare our Raspberry Pi. We need to install some kind of operating system onto the memory card. So let's start with that. So I have here this small memory, and I'm going to connect it to my computer using an adapter here. And to put an image on this memory card, we're going to use the Raspberry Pi imager. And let's just pop down here. It looks like this. So let's pop into raspberrypi.com/software. So here we have the Raspberry Pi imager, and I'm going to download it for Windows. And it's going to ask us to install it. So let's do that. I'm going to use English. Next. I accept. Next, next, next. And it's done. There we go. And then we can launch our Raspberry Pi imagers. Let's do that. Now in here, we can select the device. So if you have another kind of Raspberry Pi, you can just select the one that you have. But what we're going to do, we're going to do choose device. Going to go to Raspberry Pi 02W. That's the one we have. We're going to choose the OS. And for this, we could use the Raspberry Pi OS 64 bits, because this, as far as I understand, is a 64-bit processor. But we don't have enough memory to actually benefit from using 64-bit. So we're just going to skip that one. And these two has Debian Bookworm with a desktop. And we don't need that either. We can just use the command line prompt. So we're going to pop into the Raspberry Pi OS Other, and we're going to select the Raspberry Pi OS Lite, because that way we're not going to have that desktop in there. And we're going to select 32 bits. And choose the storage. And this is the correct one. So let's select that one. Click Next. Would you like to apply OS customization settings? Yes, we would like to do that. So here we can set the host name. The default is going to be raspberrypi.local, and I guess that's fine. We can set up a username and password, and we would definitely want to do that. I have the username Jimmy and the password 1234567 We have our wireless LAN, so let's connect with that as well. And we have the country SE. We can also set locale settings, and also let's do a Swedish keyboard layout. But now we come to the most important part, and that is services enable SSH, because otherwise we will not be able to connect to this device, and, well, we definitely want to do that. So let's save that, and let's go to options, and, well, we can just keep this as is. So let's click save. So now we have all these OS customization settings. Let's use them. The device will be erased. I'm okay with that. So now it's preparing the image. It's putting all of these settings in there. So far, I have not been able to automatically connect to the Wi-Fi. So I'm going to show you how you can do that as well if you run into the same problem as I have. Now this takes a little bit of time to write to the memory card, and also it's going to verify it so everything is okay. So now it's verifying. Now looking at a lot of tutorials to get this working, for me it was kind of tricky to grasp the whole thing. There was a lot of moving parts, and it was kind of difficult to understand what we needed to do and what we perhaps did not need to do. So this walkthrough is going to be more my experience of what you need to do to make everything work. So let's press continue, and we have a working memory card, or at least we hope so. So I'm going to put this into the Raspberry Pi. I'm going to connect the USB cable. So hopefully this will start to boot up. I'm going to switch over to the Raspberry Pi now. So now we can see it booting up. It is apparently generating some SSH keys, and it's going to reboot once. To this Raspberry Pi, I've connected a wireless keyboard. So this is the one we're going to use. So there we have it running. So the Raspberry Pi login, let's type in Jimmy and the password. There we go. Boom, we're logged in. We have our memory card, we have our Raspberry Pi, and it's now running a Linux distribution on that device. And if I just bring in my camera here, you can see it in action as well. And if you see down here, you can see that the LED is blinking, which is the read and writes to the memory card. And we're going to reuse that in just a bit. So the first thing we need to do is turn on the Wi-Fi. I know that some people have done the same thing as I have done so far and actually got connected to the Wi-Fi by default. I have not been successful with that, so if you find yourself that you're not connected to the Wi-Fi at this point, you can follow these instructions. So what we're going to do sudo nmcli radio Wi-Fi on. So now we turned on the Wi-Fi. Next up, we're going to add our credentials. So we're going to go sudo nmcli dev Wi-Fi connect the Wi-Fi SSID followed by password, and then the password to the wireless Wi-Fi. Now, I'm not going to share that one. So once we've done that, it's going to say connected, and well, we now are connected to the Wi-Fi. That means that this device now have an IP, and we should be able to use SSH to connect to it. So let's see if that's true. So on our PC, we're going to start the Windows terminal. There we go. And we're going to try to connect to SSH, or SSH Jimmy, the username, at raspberrypi.local. So hopefully this works. It does. Awesome. Yes, we want to continue connecting to this device. There we go. So what's the password? Well, we know that one. There we go. Boom, we're now connected with SSH to our Raspberry Pi. Cool. There's a lot of things that we need to install onto the device to get .NET 9 up and running on the device. Luckily, Pete Gallagher, a fellow MVP, has done this for us. He has created a script that we can just use to get everything set up. So you can check out this blog post. I will link it in the description below. But the only thing that we need to do is, if we go down here, you see that we have this script. I'm going to copy that. I'm going to go over to our SSH and simply run this. So this is going to install all the things that we need to get .NET 9 up and running on the Raspberry Pi. Now this takes a little bit of time to get all of this set up. I'm so happy that Pete did this work for us, because all of these different things were different things that we had to run in the command line here. And this makes it just so much easier. And there we go. It took about 3 minutes to install all of this. Awesome. So our Raspberry Pi has OS and .NET 9 already installed. Sweet. So at this point, we are all set up. Now, we do need to do one more thing for the next step. And that is the LED that we are using are currently showing when we're reading and writing from the memory card. And that's awesome, but we want to control that one. So we're going to run a little bit of code here. We're going to say that echo none sudo t sysclass LEDs act trigger. So basically what we're doing is that we're turning off the trigger that triggers the LED based on the memory card, like that. So what we can do is that we can do like this. Let me zoom in just a little bit here. So echo 1, so we're writing 1 to the sudo t brightness of the act LED. So if we do that, and I'm going to pop into that we can see our top camera. As you can see now, when we turned off the trigger, it's no longer on. So now if I run this, you see that the LED turns on. And we can do the exact same thing, but with a 0 instead. So we're doing echo 0, turning it off. And now if I run that, you see that the LED turns off. So we have full control over the LED. Now we could have done this in a setting file, but now this switch is only going to be until we restart the device. And speaking of restarting the device, after we have run the script from Pete, we should also restart the device. So let's do that now. So sudo reboot. And we can see that the light is now blinking. So what we did was sudo reboot to get our Raspberry Pi restarted. And as you can see, the LED is now on because we have rebooted it and the trigger is now back in business. So let's connect to the device again. The password, there we go, awesome. And let's turn off the trigger again. There we go, and the LED is now off. Perfect, all set up. Now, let's build something. To do this, we need our trusty friend Visual Studio, so let's create a new project. Let's go for a Blazor Web App. Let's call it Blazor Pi. I'm going to put it in Meadow Blazor, that's perfect. So let's go with that. .NET 9, absolutely. We're going to use the interactive render mode server. We're going to have that render mode globally. And, well, let's include some sample pages so that we can see that we have it running. Let's create it. Now, if I would grab this and just put it on Raspberry Pi, we would be able to execute it and run it. But we're going to make it a little bit more fun. So we're going to use Meadow to control the LED. So let's go to dependencies here and add a new NuGet package. This one is called Meadow Blazor. That's the one we want. And install that one. Perfect. So let's go into our Pi here. Let's create a new file. Let's call it Meadow application. And if you saw my last video, we talked about this and we created something called a desktop application. So we said that the Meadow application should be a desktop application, and the desktop application would then communicate via USB with a device. But now we're running on top of the device. So in this case, we don't need a desktop application. We just need to run it directly on the Pi and communicate with the Pi. And we can do that. What we're going to do is we're going to pop in here and we're going to inherit from app meadow.raspberry Pi. So we're saying that the Meadow application should inherit from app and it's running on top of a Raspberry Pi. Let's see that we can add those namespaces here as well. I'm going to clean this up a little bit. There we go. And let's fix the namespace up here as well. So we're telling the Meadow application that you have access to a Raspberry Pi. So next up, what we're going to do is that we're going to initialize the app. So let's do an override on initialize. There we go. So to make this available, we need to get that LED. So we're going to do var LED. We're going to do a new LED. And then we're going to use the device. In this case, the device is the Raspberry Pi. So we're getting access to that right here. And it's the pins. And what pins do we want? Well, we want the act LED pin. So that is technically a pin on the device. And also make sure that we have the necessary namespaces. So we have access to the LED. Now we need to add that to the resolver .services and add an iLED LED so that we can access that LED from other services. And again, with the namespace. There we go. So this is the whole setup for the application in the Meadow framework. So now we can access the LED using the resolver from other services. So let's do that. Let's create a new folder. Services. And in that folder, let's create a new file. And we're going to call it Raspberry Service. So what do we want? Well, we want to be able to access a LED. So let's write some code for that. We're going to use a public iLED and simply make a property out of that one. So this means that for the page or the component that is using the Raspberry service, we're going to be able to run methods on that LED object. Let's create a method called initialize async, because the problem that we can run into when we're using Blazor like this together with the Meadow framework is that Meadow or the Meadow application might start up slower than Blazor does. So we might end up in a situation where the Meadow application haven't started yet, so we don't have access to the LED, but this service, which is going to be a singleton, actually has started up earlier. But if we don't have access to the Meadow application, well, we're going to run into some problems. So what we're going to do here is that we're going to use initialize async and make sure that this service is going to start up, wait for the Meadow application to start up, and then continue. So inside the initialize method, we are going to, while we're trying to get the LED from the resolver, resolver.services.getILED, and if that is no, we're just going to wait a little bit longer. We're going to wait 100 milliseconds for that to happen. And we're going to loop that until we have access to that LED, because we need to have access to that LED for this application to work. And then we need to actually run the initialize async method. So let's do that. So we're going to do a constructor, Raspberry service, and simply run that method. We're not going to wait for it. I know this is kind of a funky way of writing, I guess, but we need to make sure that we have access to that LED, and we need to make it start up in its own time. Okay, so we have our Meadow application and we have our Raspberry service, but we don't have anything that's calling or using the Raspberry service, and we haven't set up the Meadow application just yet. So let's do that. Let's pop into program. Let's add services, singleton, and the Raspberry service, like that. And we need a little bit of namespacing here. There we go. And also down here, we're going to add use Meadow and connect that to the Meadow application. And add some namespaces. There we go. So let's go into components here. Let's go into pages, and we're just going to reuse home here. So inside our home here, let's remove some stuff here. So let's add a namespace, Blazor Pi services. We're going to inject the Raspberry service. Let's add a LED so that we know what we're doing here. Let's add a code part here, like that. So let's create a method here, a toggle method. So if service.LED is not null. So we're actually null checking here as well. We should be pretty confident that it's not null at this point, but well, since it can be null, we should always check for that as well. So service LED is on. We're going to set it to the opposite. Like that. So now we have a method that will toggle the LED on or off every time we click a button. But we don't have a button, so let's add that as well. So let's add a button. This is a BTN and a BTN primary using the Bootstrap classes. So on click, we're going to run the toggle method. And, well, just call it toggle LED, like that. So let's try and build this and see what happens. It's working. Awesome. So I'm going to go up here. I'm going to right click. I'm going to go publish. We're going to go with a folder. Let's keep the default here. I'm going to finish, close, and then publish the application. Now, there are ways of publishing directly via SSH to the device itself, but that's not going to be part of this video. If you think that this is interesting, let me know and I can do a future video on that topic. But for now, we have just published this to a folder. So let's navigate to that folder, and you see that we have a lot of stuff happening here. Great. Now, to get it over to the device, we can use a program called WinSCP. So I'm going to install that one as well. So you can find it at winscp.net. So download. There we go. Let's install the application. Accept. Typical installation, that is fine for what we're doing. I prefer to use the Explorer compared to the Commander, but well, that's just preferences. And install. Finish. Awesome. So let's start WinSCP. So here we have it. We're going to use SFTP. We're going to do the host name, and that would be Raspberry Pi. Raspberry Pi.local by default. I have had a little bit of trouble getting the Raspberry Pi.local to work. So if you have any problems with that, figure out what the IP address to that device is, and you can do it that way instead. And the username would be Jimmy, and the password is something that we know. So let's save that. This is fine. Let's see if we can connect. So again, with a fingerprint, well, accept that. The password, we know that password. Okay. And boom, we now have access to our device. So I'm going to go to the home Jimmy folder here, and I'm going to grab our publish files here. I'm actually going to grab that whole folder, drag it over here. So upload file published to the remote directory. Yes, I want to do that. So now it's grabbing all those files, pushing them over to the Raspberry Pi. Cool. So now we should have a folder called publish inside of our device. So let's go back to our Windows terminal. And let's do ls. And look at that, we have a publish folder. Let's go into that publish folder using the correct command. There we go. Let's have a look. So we have all of these files. So now we want to be able to run this application. But if I just would run this application, it would start up and using a non-standard port. I wanted to use the port 80. So what I need to do is that I need to run this command. So sudo .net blazorpi.dll, and then what URL I wanted to hook up on. So in this case, it's going to be the whatever IP I have and port 80. So let's try this. So now our website is starting up. It's listening on port 80. That's really cool. Let's see if this works. So let's pop into a web browser. Let's go to Raspberry Pi local here. And I'm going to bring in the Raspberry Pi here as well. So now if I click here, you'll see that the LED toggles. I have a couple of presentations where I talk about different stages in my life. And the first one was when I got my first computer, wrote my first lines of code. That was the defining moment when I realized that I wanted to become a developer. Then came other stages, like I realized that I can write code on something that I can bring in my pocket. Calculators in school, phones coming next, and all of that stuff. And then when I started using these kinds of IoT boards, I realized that I can make a LED blink. And I still remember that moment when I just got the LED to blink. It was such a defining moment. It was such a fantastic moment. But I gotta admit that having a Blazor application running on top of that IoT device, serving that to me, as well as having a UI that I can click to make the device do things, that's another level. So I definitely encourage you to try this out. And please like, share, and subscribe. And please let me know what you would like to see next on this channel. Until the next time. You're still here? This is me just playing around, so you can go now. No, but seriously, the video is we're already done. I'm just playing around with this. I mean, it's a UI that I can click on my computer and the LED is doing stuff. It's blinking. Well, you gotta try it. You gotta try it.